right, you guys, rewrite each of the following expressions using properties of exponents. Gosh, I feel like by now we are all experts on properties of exponents. So I think this one was weird. This top one is just here. Here. All right, so power to a power, we just multiply. So 5 squared becomes 5 to the 6th power. B to the negative 4th becomes B to the negative 12th power. 3 to the negative 2 power becomes 3 to the negative 2 power. And B to the negative 10th power. And then I'm going to rewrite it because anything with a negative exponent can be put on the denominator. So 5 to the 6th power is going to be the only thing on the numerator. And on the denominator is going to be, I have B to the negative 12th, B to the negative 10th. I add those because I'm multiplying. It's going to be B to the 22nd power. 3 squared is 9. And I would say 5 to the 6th power is actually a number, but it's probably a pretty big number, and it might be easier just to say 5 to the 6th power. Let's see. 5 to the 6th power. I mean, so technically, well, is that divisible by 9? We might be able to do this better. Let's see. Is that number? Nope, not divisible by 9. So I would just say leave it like this or change it to 15,625. 15,625 on the numerator. Okay, but that's up to you. I would have left it as 5 to the 6th power. All right, second one, and actually, you guys, let's give myself some more room. I'm gonna erase this. Okay, so same thing I just did, except I'm gonna have a numerator and a denominator. So I'm gonna have x to the negative, you got to remember your PEMDAS here, x to the negative 3 times x to the negative 4, right? I did this and this because exponents come before multiplication, so I will multiply these x's together, but not right now. I had to do the exponent first. Y cubed z, okay, over, and then the denominator just stays the denominator. X, y to the negative 4th, z to the 4th. Now, anything with the negative on the numerator, I'm going to put on the denominator, and anything with the negative on the denominator, I'm going to put on the numerator to make it positive. So my x's, both of these x's are going to go into the denominator, and I'm going to change it to the 7th power. So x to the 7th power, but we're going to have this x here too, so I'm going to make it x to the 8th power on the denominator. And then this y to the 4th, I'm going to bring up, but it's going to combine with this, which is going to be y to the 7th power. And then I'm going to cancel out this z up here with one z down here. So my z becomes z cubed. So, and then erase this extra bit here. All right, and so my final answer would be y to the 7th power over x to the 8th z cubed. I'm going to delete this now. All right, what's next? So if I have something to the 3rd power, that means both my numerator and my denominator are going to be to that power. So the first thing I'm going to do is rewrite the numerator, power to a power. Okay, and don't forget, our numbers actually have an exponent also. This is 2 to the 1st power. So my new numerator is 2 cubed x to the negative 6th power. Hold on. All right, and y to the 9th power over x to the negative 15 power, y to the 21st power. Okay. Everything with a negative exponent, I'm going to switch them. And I'm going to change my 2 cubed to be 8. And then so I'm going to have x to the positive 15th, y to the 9th over x to the positive 6th, y to the 21st. Okay. Now I can simplify some of my exponents because I have the same base base value on the numerator and denominator. So we can have 8, but I can take away all my x's on the denominator and subtract them from the numerator. So it's going to be x to the 9th power, right? 15 minus 6 is x to the 9th power. And then it's going to work the opposite way. Since I have more y's on the denominator, they're going to stay there. And 21 minus 9 is 12. So it's going to be y to the positive 12th down here. Okay? And I think that's the most I can do for that one. All right, last one. These are annoying to do all together, aren't they? Okay, last one. So same thing. I'm just going to multiply the numerators, multiply the denominators. A to the 6th power to the negative 2/3 power is a to the, and so look over here. I'm going to do 6 over 1 times negative 2 over 3, which is negative 12 over 3, which is the same as negative 4. So this is actually just going to be a to the negative 4th over, I'm going to do the same thing. So 27, oops, not 27, but it's, you know what I might do though is 27 is the same as 9 squared or 3 cubed. So I'm going to change 27 to be 3 cubed right here. Okay, and then I'm going to take the 3, which is the exponent, and I'm going to say 3 over 1 times negative 2/3 is equal to just negative 2. So over 3 to the negative 2 power. Since both are negative, they're just going to flip. So I have 3 squared on the numerator, and I have a to the 4th on the denominator, which is just 9 over a to the 4th, I think is the most simplified we can get for that one. All right, what's next? More properties of exponents. You guys better get these all right on the test. We are practicing, practicing, practicing. Oh. Did I skip one? Let me see. Nope, it's good. Okay. All right, 64 to the 2/3 power is the cubed root of 64 squared. Evaluate each expression without using a calculator. Okay. So what does that mean? 64 squared is the same as the cubed root of 64 times 64, right? Which is the same as 8. 64 is the same as 8 times 8, right? So this is the same as the cubed root of, let's see, 8 times 8 times 8 times 8. Each 8 has a cubed root of 2, so I'm taking out 2, 4, 6, 8. So the cubed root of 64 squared is just 3, 2, 2, 2, 2 is just 8, because I take out 2 for each 8, so 2 times 2 times 2 times 2, 2 times 2 is 4, times 2 is 8, times 2 is, 16. So equals 16. Now, is there an easy way to do this? Well, let's take a look. Is there an easier way to do this? Because as I was doing this in my head, I was thinking, what if we had turned 64 into 8 squared, and we had 8 squared to the power of 2/3. And when you have something power to a power, you multiply. So this would have been 8 to the power of 4 over 3, multiplied my numerators, multiplied my denominators, which is the cubed root of 8 to the 4th power, which is 8 times 8 times 8 times 8, and the cubed root of each 8 is 2. So we take out 2 to the 4th power, which is the same as 16. So 2 ways to do that. Let's see. How about 125 to the 4/3? I can change 125 to be 5 cubed, okay? And if I take 5 cubed to the 4/3 power, then my 3's cancel, and I just have 5 to the 4th power, which is 125 times 5, 625? 625? All right, and let's see. You could, of course, it says without using your calculator. You could always check with your calculator. On the SAT, if you are able to use your calculator on that section, please do. 81. So here's what I thought about the last one. To the 3/4 power. Is there a way I can make 81 from a number to the 4th power? And I think it's 3 to the 4th power. Is that 81? 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 9 is 81. And the reason that works is because now when I take it to the exponent of 3 to the 4th power, the 4's are going to cancel because one's a numerator, one's a denominator. Then you just have 3 cubed, which is 27. Okay? Okay, let's do this last one on this video. All right, 27 over 8 to the negative 2/3 power. So can I make each of those? 27 is 3 cubed. 8 is 2 cubed. And if I take each of those to the negative 2/3 power, the 3's cancel. So I have 3 to the negative 2 over 2 to the negative 2, which is the same as 2 squared on the numerator over 3 squared on the denominator, which is 4/9. All right, I think we're done with this part of the exponents. Maybe, nope, use property to solve the next one. All right, well, we'll keep going then.